Okay na?
Okay na? Hi, I'm Carl.
I'm Sherry,
And we are going to talk about rigid disk drive.
Rigid hard or fixed disks contain control circuitry and one or more metal or glass disks called platters to which a thin film or of magnetizable material is bonded. These platters are stuck on a spindle which is turned by a motor located within the drive housing. These can rotate as fast as 15,000 revolutions per minute, the most common speeds being is 5400 RPM and 7200 RPM. The read or write heads are typically mounted on a rotating actuator arm that is positioned in its proper place by a magnetic fields induced in coils surrounding the axis of the actuator arm. When the actuator is energized, the entire comb of read-write heads moves toward or away from the center of the disk. Despite continual improvements in magnetic disk technology, it is still impossible to mass-produce a completely error-free medium. Although the probability of error is small, error must nevertheless be expected. Two mechanisms are used to reduce errors in the surface of the disk: the special coding of the data itself and error-correcting algorithms. These tests are handled by circuits built into the disk controller hardware. Other circuits in the disk controller take care of head positioning and disk timing. In a stack of disk platters, all of the tracks directly above and below each other form a cylinder. A comb of read-write heads accesses one cylinder at a time. Cylinders describe circular areas on each disk. Typically, there is one read-write head per usable surface of the disk. Fixed disk heads never touch the surface of the disk. Instead, they float above the disk surface on a cushion of air only a few microns thick. When the disk is powered down, the heads retreat to a safe place. This is called parking the heads. If a read-write head were to touch the surface of the disk would become unusable. This condition is known as a head crash.
Seek time is the time it takes for a disk arm to position itself over the required track. Seek time does not include the time that it takes for the head to read the disk's directory. The disk's directory maps logical file information, for example, my_story.doc, to a physical sector address such as cylinder 7, surface 3, sector 72. Some high-performance disk drives practically eliminate seek time by providing a read-write head for each track of each usable surface of the disk, with no movable arms in the system. The only delays is accessing data are caused by rotational delay. Rotational delay is the time that it takes for the required sector to position itself under a read-write head. The sum of the rotational delay and seek time is known as the access time. If we add to the access time the time that it takes to actually read the data from the disk, we get a quantity known as transfer time, which of course varies depending on how much data is read. Latency is the direct function of rotational speed. It is a measure of the amount of time it takes for the desired sector to move beneath the read-write head after the disk arm has positioned itself over the desired track. Usually cited as an average, it is calculated as 60 seconds per disk rotation speed multiplied by 100 milliseconds per second and divided by 2. Because the disk directory must be read prior to every data read or write operation, the location of the directory can have a significant impact on the overall performance of the disk drive. Outermost tracks have the lowest bit density per areal measure. Hence, they are less prone to bit errors than the innermost tracks. To ensure the best reliability, disk directories can be placed on the outermost track, track 0. This means for every access, the arm has to swing out to track 0 and then back to the required data track. Performance therefore suffer from the wide arc made by the access arms.